Hey guys, it's Uygar. We are back with, guess what, another Kaggle competition. We will be solving CommonLit Evaluate Student Summaries competition. As usual, I will explain everything word by word, line by line, so that you have a clear understanding of what's going on. If you stay until the end, you will learn all the tricks and strategies I use to solve this competition, and you will make your own Kaggle submission. So make sure you do. You can use such projects to strengthen your portfolio as an engineer or developer, or strengthen your Kaggle profile, whatever, but most importantly, you will learn how to approach and solve such problems. Before we begin, if you like what you see, you can support the channel by hitting that like button and subscribe. Which competition should I solve next? Let me know in the comments. Okay, let's start by reading about the competition. So the goal is to assess quality of summaries written by students grades 3 to 12. Okay, what we are going to do is basically assess quality of summaries. So we can say that it is a regression problem. We have some context over here, like what it is for, what is going to be used for, some acknowledgements. We have the evaluation. We are going to use column-wise root mean squared error, which we will use as our loss function. After that, we will have a submission file, how it's going to look like, prices and blah blah blah. Okay, let's look at the data. So we will have 2 train and 2 test files and 1 subsample submission file. For the test, we will have a prompt question, title of the prompt. Let's show it from the train. Title of the prompt and the text. The text is then a prompt text. Okay. And we go to the samples summaries train. We will see the text. Okay, this is the important part. This is the summary. This is what we are going to evaluate. And we will evaluate it on 2 scores, content and wording. If it is all clear till now, let's go into the code. For that, we just click code. And by the way, this is an ongoing competition. We say new notebook. After we open the notebook, we will encounter with this screen. The first cell just gives us the paths of the file, so we can just delete it. First thing we want to do is we want to turn off the internet, because this competition doesn't allow the use of internet. The next thing we want to do is we are going to use Datasets, v3, and we are going to use a spell check library. We use spell check library because this is summarization of students and they can make typos. We want to correct them, and this actually improves the results. To do that, first we go to add data and we say Datasets v3 base. Let's say we can use this. We say add dataset and it says adding data source. After that, we want to go here and say autocorrect and we add this too. After that, you should see them added as your input files. With this done, let's go to importing libraries. First, we added the autocorrect library, so we want to install that. We say pip3 install. We go to autocorrect, we copy the path, and we just paste it. Okay. After that, we need pandas. We need transformers. We need other stuff from transformers. Import, we will use Datasets, v3, Tokenizer, fast, and Datasets v2 for sequence classification. So I said we are going to use Datasets v3, but I loaded Datasets v2. It is okay, we are going to use the library of Datasets v2, but we will load the weights of Datasets v3 it serves the same thing. We will need torch. We will need from torch import Optim for our optimizer. From torch.utis.data import, we are going to Dataloader to load data, to create datasets, to split the dataset. Okay. After that, from torch.nn, we will import the loss function. We will need numpy, we will need random. I will estimate the time, the training time, so I will import time it. After that, I will import TQDM. For TQDM, it will give us a pretty bar. And we installed autocorrect, and we import that. We run the cell. It may take a while to install the library. Okay, we made a typo, import pandas as PD. Let's run it again. We installed autocorrect, we import the libraries. Now let's define some hyperparameters. Okay, first let's start with random seed. I set it to 42. Let's give a model path. We will use the Berta v3, so we just copy the path, paste it. Max length 512. Actually, we will see how I decided 512. But for now, we can just say 512. After that, we have batch size. This depends on the GPU, but for us, 8 is okay. Learning rate 2e minus 5, my preference, do whatever you want. Epochs equals to 2. Again, you can decide it for your own too. It just worked fine for me. And we have to assign random seeds so that we will have a reproducible code. We can get the same results when we run it separately. We say again, we give our random seed and torch.manual seed. We are going to define some random seeds. Let's just copy this. Manual torch.qda.manual seed. Okay. And we are going to do seed all. Okay. After that, torch.backends.qdnn.benchmark up equals to true. We give this true. And so sorry, not benchmark. This is deterministic. Benchmark is false. Let's just copy this, paste it here. Let's say benchmark. And okay, this is false. Alright. Now we have to set the device, whether we are on GPU or CPU. QDA if torch.qda.is available. Okay, else CPU. We say that if we have GPU, use QDA, else use CPU. I want to silence some warnings from the transformers library. We do it by utis logging dataset verbosity error. It just silences some warnings. Like I mentioned, we will use spell check, so we define it here. Autocorrect, that's speller. Language, choose English. And I use fast equals to true, but if you like, you can omit it. It just takes longer for it to run. Now let's run it. Okay, we made a typo. Where is it? Alright, let's transformers. Okay. Now it's time to load the data. So we have train summary data frame. We can load it by pandas.read CSV. Let's come here and let's find summaries train, copy this path and paste it. After that we have train prompt. Okay, same procedure, we come here, we copy the path and paste it. Okay, after that we have test prompt, test summary df. We come here, summary test, we copy that, come here and paste it. Now let's copy that and we are going to do it for test prompt. Test prompt df, we go to here, prompt test CSV and paste it here. Let's not forget commas. As last we have the sample submission file, so we call it submission df pd.read CSV. Okay, sample submission, copy it, paste it. Let's just check one more time. Summaries train, prompts train, summaries test, prompts tests, sample submission. Let's run this. Okay, we loaded the data. Now let's check how they look like. But first of all, for train, for summaries, what we are going to do is we will correct the spelling mistakes of the summaries, which is in text column. We do that by assigning train summary text column, another train summary df text column, and we are going to apply. Okay, what this does is you give a function and it applies that function to every element of this specific column, in this case text column. So I like to use lambda for this. So what this does is I take x as an argument and I return this spell x. I define spell here, it corrects the spelling mistakes and returns it. Let's check train summary df.head. Let's see how it looks like. Okay, everything seems fine. We have the text, we have the content, wording, etc. Now let's look train prompts df.head. Okay, we have prompt IDs, prompt question, prompt title, prompt text. This is all clear too. Now what we do to train the spelling correction, we will do it to test. This is by test summary. Actually, we can just copy this, This is test summary. Just replace the train with test and it takes care of the rest. As you can see, this is a dummy data for this test. We have student ID, prompt ID and text, which is okay, what we expect. We just take the text and we are going to classify it. Let's look at test prompt df.head, how it looks like. Okay, we have the text prompts, all right to prompt title, prompt text, ID and the question. The last file is submission df.head. For that we will give student IDs, we will have content and we will have the wording. These will be our scores and this is the ID of the text. Next, let's load our data model. First we will load the tokenizer, which is data v2 tokenizer fast. We use the fast because it is implemented in Rust and you guessed it, it is faster. So I use that. Say from pre-trained, okay, we give model path. Now for the model, we say Deberta v2 for sequence classification that from pre-trained. Okay, we give model path, but we will give additional parameters. First, we will give number of labels equals to 2. Why? Because we are going to predict two values, content and wording. So we set number of labels equals to 2. What it does is it actually changes the loss function. If we set it to 1, it says this is a regression problem, but for only one label. So we did that before, but since we have 2 labels, we will set number of labels to 2 and we will define the loss function on our own. After that, we put this model to device. In this case, it will put it into GPU. Okay, now what we're going to do is we have 2 files, as you can see. We have summaries and prompts. What we are going to do is we will merge them both and we will merge the prompt question with prompt title, okay, and we will merge it with text. So what it does is we have to somehow give them all to the model at the same time, and we will give it by using a special SEP token, which I will show you in a second. First of all, let's merge them under a data frame called train.df, train prompt, let's say, and we say merge train prompt df. We say merge with train summary df on equals the prompt id. Now what it does is it takes the train prompt df and it takes the train summary df, train prompt df, train summary df. It takes the prompt IDs and matches them and merges them. After that, like I mentioned you, we have to give all this information to the model at once somehow. That's what we are going to do here. We will create a new column called inputs. At that column, what we are going to have is we will have prompt question. We will add that as space. And we will add prompt titles to that. These all gives additional information to our model. Prompt title. We add again another space. After that, we will add a special token called SEP token. What is this? Is that, maybe you have seen this token. This is usually at the end of the sentence. But we will give it in the middle so that we tell the model, we merge them, these are separate, but also at the same time we can receive input IDs, attention masks and everything. So that's what we are going to do. Train, we will add text for this. That's okay. Another way to do this, actually, you can pass 2 arguments into Tokenizer. That's how I did in the previous videos. But for this, I found it more I found this easier. Okay, convenient. Yeah, that's the word. Let's check this. We added inputs, and as you can see, our inputs here. We added prompt question here, and let's actually check this. Train df, inputs, and how it looks like. As you can see, we have the prompt question, at least 3 elements of an ideal tragedy as described by Aristotle. On tragedy is our prompt title. And the SEP token, I mentioned, special token. And after that, we have the student summary. This is working well, so we can just click sell. Now we do the same for the test data. Let's just copy paste it, say test df. Let's change this, test prompt df, test summary df. This is tests df, this is also test, this is also tests, and this is test2. So many tests, okay. As you can see, summarize blah blah, example title 1. Okay, this is the prompt title, special token, and the text. Okay. In the beginning, I mentioned you that I decided max length somehow, and I'm going to show you. Now it's time for that. How we're going to do that is we will define a variable called max length. We will be our max length. We take the train and we will take the inputs, which will be the input of our model. And we say apply. We say lambda x. Like I mentioned before, x is the every value in the column. And we take its length. After that, we take the maximum of it. Let's see what is the maximum length. Okay, this is a big number for every model, and it will take lots of training time. And we just looked the examples here, and they don't seem that long. So what I thought and think is this is a noise. This is a specific example that is too long. So we will check the others. How we are going to do that is, again, we say train df, we say inputs, we take strings, and we say take length. And after that we say as described. As you can see, this is the number of data, this is the maximum. Now let's look at the mean. The mean number is 563. This is the mean of the length of the inputs. So yeah, this was a noise. And we have to set the max length around here. So that's why I decided 512. Okay, with that out of the way, let's continue. We will have two datasets. First is for training and the second one is for testing. Let's start by training. Class summary train dataset is how I name it. We give the dataset as argument. And since it is a PyTorch dataset, we will need three functions. First one is init. We will take inputs as argument, content, our first scoring metric, and second one is wording. At last, we will take the tokenizer. Now let's assign self-scores to torch.tensor list of x for x in zip, content, and wording. So what I did is I basically put content and wording together into one list, so that in the while training we can just get them together. Okay, that is the idea here. After that we say self-encodings and we encode the text, which is inputs. We say padding equals to true. We say truncation equals to true. We say max length equals the max length that we just decided. Second must argument is the length. We just say self. We don't need anything else. We can just return the length of the scores. Okay. The last argument is getItem. This is what the dataset is going to return when we call it. We will ask for an index. We will say outtick. What we are going to do here is we will turn the values into torch tensors. Okay, torch.tensor value index for key and value in self.encodings.items. Okay, and we will add scores to our output dictionary, because that's what we are going to use while training. We just save scores and we take the index for that. And at last we return outlick. This is for the training. Next we will need submit dataset. This dataset is where we are going to use doing predictions. Summary, submit, dataset. Again, same procedure, very similar. We say init, self, inputs. Instead of content and wording, since it is testing, we are trying to predict them already. We will take IDs so that we can match them. IDs, and we take Tokenizer. We just self.IDs equals to IDs instead of self.scores. And this is the same. Length is again nearly the same. Self, instead of scores, we return length self.IDs. That is done too. At last we have get item, self, we have the index we are looking. Again, we have output dictionary, we say key. The same thing, we are converting them to tensors so that our model can process it. For key, we give value and self.encodings.items. Instead of scores, we add outlick IDs to here, self.IDs index, and we return it. Turn outlick. Okay. Invalid syntax, where is it? Line 11, outlick scores. Okay. There is an equal line. Alright. Now let's check if our dataset is working or not. For that, first of all, let's define the dataset. Summary, train, dataset. We say train df, inputs as the first argument, and we convert it to list. Again, train df, content, that to list as the second argument. Train df, wording, that to list as the whatever argument, and last we have the tokenizer. Let's again take this here. Okay, tokenizer match, wording matches, content matches, inputs, it also matches. Let's actually print the values and see that it works. Okay, say print, first let's take the length of the dataset and let's take a sample value, dataset 0. After that, let's just print this again. Let's do the same for test dataset, equals to summary, submit, dataset. Again, this is not all same. Test df, we give inputs. We put them into list. We give test df, student ID. That's what we are going to give for IDs. To list, and at last we give tokenizer. After that, print length of test dataset. Print test dataset 0. We get item here, and let's just end it after that. Let's see if this works. Okay, we have the length, and as you may see, same length in the describe. We have input IDs, token type IDs, attention masks, and scores. This works fine. Summary submit dataset is not defined. We did a typo here. Summary submit, yes, this is going to be submit. Let's run it again. Okay. Another error. test dataset 0, torch val x, okay, and which one in the test part? What's wrong with it? Let's go here. Our error is around here. Self torch. Okay, let's compare it with this. Key torch. That tensor. Okay. Let's try this again. And yeah, it's working now. At last we have input IDs again, token type IDs, and regular IDs. So it is fine. Okay, maybe we can continue. Next thing we want to do is we want to split the trained dataset into validation so that we can get validation loss during the training. We do that by we define a generator torch, that's generator that manual seed, we give random seed. After that we give train dataset and val dataset. We use random split that we imported dataset. We give the ratios 0.9 to train, 0.1 to validation, and we say generator equals to generator. After this is done, let's put them into data loaders. To do that, first we will define train data loader as data loader. Loader dataset equals to train dataset. Okay. Batch size equals to batch size. And I want to shuffle it. Equals to true. We do the same for the validation and test, so we can just copy paste it. Okay, this is val dataset, I want to shuffle it, and this is validation data loader. We do the same for test, we go here, rename it, we say test, dataset equals to test dataset, and I don't want to shuffle. With that out of the way, we can go into the training loop. Okay, for that, let's first define the optimizer. Is optim.addonV is what we are going to use. Model.parameters, yeah, I wrote it correct. Learning rate equals the learning rate that we defined earlier. Like I said, we are going to define our own loss function criterion, MSLE loss. Reduction equals to mean. Okay. I wanna estimate the time, so I'm going to start a timer. Time it. That default timer. After that, for epoch in TQDM range epochs. Basically, we will iterate every epoch. Position equals to 0, leave equals to true, makes the 2QDM bar stay where it is. After that, we take the model into the train mode. The train, because we are going to do the training. We define train running loss, which is the loss of the epoch, train loss of the epoch. And we will iterate with index and sample in enumerate. Again, we will use 2QDM. We will iterate train data loader. Okay, we will iterate position equals to 0 for TQDM. This is like I mentioned. Okay, after that, we will just take input IDs from sample. Input IDs. Input IDs. And we put it to device. Because, you know, the GPU, the model and the data has to be on the same device, so we put input IDs to device. Next, we take attention mask, sample, attention, mask to device again. At last we have the targets, which are the scores. Probably I will make a typo here, to device. Okay. After that we can just take the outputs from the model. We take input IDs equals to input IDs, attention mask equals to attention mask. We get the logits from here and we define our loss here. Criterion, we give targets and outputs, logits. After that we say optimizer.zero grad, which these lines make sure that training is happening. Loss that backward, optimizer.step, and we calculate the loss, train running loss, plus equals the loss.item. We get the loss value from the loss with this. Okay, after that we completed the calculation of the loss too. Now we need the train loss of the epoch. How we are going to do is train learning loss. We take this and we divide it with index plus 1 in parentheses. Okay, the training part is done. Now let's do the evaluation part. It is very similar. We put the model in evaluation mode so that we make sure no training is happening. We define our first loss. We have predictions. Actually, we don't need these. We don't need predictions and goals because we are just going to calculate the loss. Okay, we say with torch.no grad. This makes sure that no gradient update, hence training is happening. Same thing for index sample in enumerate, TQDM, val Dataloader, position equals to 0, leave equals to true. Okay. Again, the same thing, input IDs equals to sample, input IDs, we put it to device. Attention mask. We go to sample, we go to attention, mask, we put it to device 2. At last we take the targets. Sample, scores, that to device. And outputs, we feed the model these values, input IDs equals to input IDs, attention mask equals to attention mask. We update the loss equals to criterion targets outputs logits. While running loss, here we update our loss.item, we get the value of the loss, and we update the validation loss of our whole epoch. Validation loss equals to while running loss divided by index plus 1. Okay, now after this whole loop is complete, we are going to print the loss values multiplied by 30, print f train loss epoch plus 1. Oops, sorry. Epoch number is epoch plus 1, and we print the train loss. I only want the 4 digits, so I say that for f. Okay, I put this, and we do the same thing for validation. We paste it here. We say valid loss for epoch. We will say val loss. After that, we will close this. Like I said, I opened the timer. It is optional, but I want to know how long it took. So I say time it, that default timer. And we will print the estimated time, training time, stop minus start, that to F. So the 2 digits is 5 for me. That's why I did it like this. And let's put the seconds. Now before starting the training, there's something we want to do. We want to go to accelerator and open up our GPU. I will choose GPU P100. Just click this, click turn on GPU. It says draft session off, and we will just click run all. And it will run all our cells. After the training, let's meet here. If there's a bug, we will meet here again. Guess what? We have a bug. Okay, no MSLE error not defined because we did a typo. It has MSE loss. Let's try it again. Another warning, unknown argument, position 0. Where? Position, no, it is position. Okay, it started training. If it goes well, let's meet you again. We are back and training is complete. Let's check the scores out. So we can see that training loss decreased by a good amount. That is what we expect. And our loss decreased too. We did the training for the 2 epochs, but like I mentioned, you can make it more, you can use other strategies. But for the sake of simplicity, we will just do 2 epochs and make it done here. Okay, now for the submission, we actually have to predict things and put it into a data frame, into a submission folder. So let's get to that part. First of all, what we want to do is torch.qda.empty cache, so that we can free up some GPU memory from CUDA. After that, we will define several lists. First is contents, which will include content scores, wordings, which will include wording scores, IDs, which will include IDs. After that, we take the model into evaluation mode, and we follow it with torch.noGrad. This makes sure that no training is happening. Torch.noGrad. Okay. Then the similar procedure for index and sample, and enumerate TQDM, test Dataloader, position equals 0, leave equals true, and yeah, let's put this column. Input IDs equals the sample, input IDs that to device, we put it to device. We are still on GPU. Attention mask equals the sample, attention mask that to device. IDs, we will extend the list of IDs. And for this, we don't need to put it into GPU because we are not going to give this to model as an argument. So we can just make it stay on CPU. Now let's get the outputs. Model input IDs equals the input IDs. Attention mask equals to attention mask, and we take the logits from here. After that, we take contents and we extend it. We turn it into float, I for I in outputs. Okay, we are going to do something a bit strange here. What it does is, if you have a PyTorch tensor and it has two columns, you just get the first column or zeroth column with this one. And for the wordings, you will get the next column, and we will do it by giving it 1. For I in outputs 1. Okay. And when we do float here, it automatically takes it from GPU to CPU, so we are storing it in CPU. It is good. Like I mentioned, these are two columns, contents on the one column, wordings on the other column, and with the 0 and 1 here, we take them both. Let's run this and make the predictions. Okay, it ran without any problems. Now we are going to the submission df. We will prepare the data frame. Data, this is big F. Lists, we take zip, we give IDs, contents, and wordings. Contents and wordings and IDs, okay, we gave them all. We give comma, and we give columns, which are, let's go to the sample submission, student ID, content, and wording. Okay, these have to match. Okay, if they don't match, your submission will give an error. Not ID, student ID, content, and wording. Okay. Okay, and after that we put them into a CSV file. Submission df.csv, submission.csv. Okay, and we have to give index equals to false. Okay, and let's actually check our file. Let's see if we get an error or anything. We have student ID. Let's double check that they match. Student ID, content and wording. Content and wording. And as you can see, here are the scores of the training. So now what we want to do is, we want to come here and we're going to click submit. Okay, as you can see, I already used 3 of my submissions while preparing this video and to make sure that everything is fine. Now let's just click submit. We click submit and it will show us this. Okay, after this run is done, complete and scoring is complete, let's meet here again. Okay, now as you can see, the notebook run is successful and the submission is complete. We can view our submission by clicking here and say view submission. As you can see, I made several submissions before, and this is the public score. You get a private score when the competition ends, but since it haven't ended yet, you only have the public score. So congratulations, you made your submission for this competition, and it is a decent score, I guess. Also, if you want to share your notebook and want to make it public, you can just come here, say share, and make it public so that everyone will see your notebook. I will make mine and I will share it in the description. Okay, I guess we can end here. Thank you for listening. That's it for today. I hope you liked the video. Make sure you subscribe to my channel. Until next time.